In this example, we have find the work done pushing a 200-pound barrel 10 feet up a 12.5-degree incline. We will ignore all forces acting on the barrel except gravity, which acts downward. Round our answer in foot-pounds in 2 decimal places. Now, when we're trying to calculate work, which is really the amount of energy that is transferred into this object, you need to think about this as we have an incline of 12.5 degrees, and we are pushing this barrel up the incline. When we are doing that, and when we are pushing into this barrel in order to make it go up that hill, then the amount of energy that's actually being put into the object is getting diminished because of the incline itself. Unless we push at the degree of the incline, then we are going to be losing some energy, as it's no longer going to be the energy of the incline, it's more so the energy going along the x-axis here. This is where the formula for work developed in this section comes from, which is work equals the force times the distance times cosine of theta, or the angle measured in between the horizontal distance and the diagonal change. Or, when thought about this in terms of vectors, this is the magnitude of the force vector times the magnitude of the distance vector times cosine of theta. Well, here this is going to be relatively simple. The amount of force we need to put into this object to make it move is the weight of it, so 200 pounds. That is where that gravity is coming from, because that's how heavy it is. Times the distance vector is how far we want to move it. That is the 10 feet of incline. That's 10 feet. And we'll multiply that by cosine of the angle measure in between. So 12.5 degrees. That's all we really need in this case. The forces that we're ignoring include things like what are called the normal force, which, if you take physics, is the force that is exerted off of the plane that the object is sitting upon. For example, I am on the ground right now. I am in my chair. And if there was not normal force of the ground pushing my chair back off of the ground, I would be more or less phasing into the ground itself. So these are some forces that we are not taking into account in this case. We're just doing the simplistic situation here. So this is really just 2,000 times cosine of 12.5 degrees, which is still going to be a hefty amount of foot-pounds, but it is going to be less than 2,000. If we approximate this using a calculator, we will get 2,000 times cosine of 12.5 degrees. Do make sure you're in degree mode, since we are plugging in a degree measure into cosine here. And we get 1,952.59 to 2 decimal places. That would be my amount of work in foot-pounds.